So let's look at an example of a problem to do with the central limit theorem, a fairly standard sort of problem. Here it is. The length of fish caught at a local jetty is normally distributed with a mean of 15 centimetres and a standard deviation of 6 centimetres. Now if we catch 25 fish at random and measure them, we want to know what is the probability that the sample mean, the mean of the lengths of these 25 fish, is firstly greater than 17, less than 14, and lastly between 14 and 16 centimetres. Let's look at each bit in turn. But first of all, we'll think about the situation. For the population of fish, the mean is 15, mu is 15, and the standard deviation sigma is 6. Now thinking about the sample, or any sample of 25, the number in the sample is 25, so n equals 25. Now, the central limit theorem tells us that the mean of the sample means of 25 fish caught will be the same as the population mean, approximately, in other words, 15 centimetres. And the spread of the means, or the standard deviation of the means for the samples, is given by the formula sigma on root n, so in this case 6 over root 25. Now square root of 25 is 5, so 6 over 5 is 1 1/5 or 1.2. So the spread of the sample means, or the standard deviation of the sample means, is 1.2. The mean of the sample means is about 15. So now we can answer these questions here in the same way as we did basic normal distribution calculations. We're going to use our graphics calculator, so we need to be in statistics mode. We're dealing with a distribution which is normal, and it's straight normal NCD calculations. Yes, we're dealing with a variable, not a list from our calculator. Now I haven't drawn a diagram here, but I'm sure we can imagine this one. If we're interested in scores for the means, the samples of greater than 17, the lower value is 17. The upper value was as far as we like, so we put in the largest number we can into our calculator, e to the 99. Now we're dealing with the spread, or the standard deviation of the sample mean, so we need to put in here 1.2. Not 6, that's for the population. We're dealing with the spread of the sample means. So it's 1.2. And again, we're dealing here with the mean of the means, but the central limit theorem tells us that that's about the population mean. In other words, we're going to put in here the population mean of 15. So now when we hit XE, we find the probability that the sample mean will be greater than 17 centimetres. And there it is, the answer is 0.0478. Using our calculator, just summarising our answer, the probability that the sample mean is greater than 70 is 0.0478 to three significant figures. Now for this one, less than 14, we go back and we put in our data now. Now, less than 14, so our lower value is going to be the lowest number we can put in our calculator, negative e to the 99. The upper value here, they have to be less than 14, so the upper value is 14. We're dealing with the sample mean, so this still applies. Standard deviation of the sample means, the mean of the sample means. So we find the answer. It is 0.202 to three significant figures. And lastly, the probability that our sample mean is between 14 and 16, putting in our correct values here now, the lower value for the sample mean is 14. The upper value for the sample mean is 16. Yes, same standard deviation and same mean. we find the answer here for a probability of the sample mean between 14 and 16 as being 0.595 to 3 significant figures.